Hi, welcome back to Learning with Stickman. Now I'm going to tell you about casting processes used in parts of aerospace industry, specifically in airplanes. Today we're going to talk about engine airfoils and nozzle guide vanes. Let's get to know each of them. Engine airfoils produces a lifting force that acts at right angles to the airstream and a dragging force that acts in the same direction as the airstream. They are made of nickel superalloy CMSX. Nozzle guide vanes direct the airflow into the turbine blades while converting pressure energy into kinetic energy. They are also made of nickel superalloy, but it's a different one, it's the C1023. In here, we can see the manufacturing process of the airfoils. First, they design the mold digitally and then make the assembly of the mold. Next, we have the casting part, the finishing, and the seal inspection is the use of fluorescent liquid under black light to detect cracks and surface discontinuities. Next, the gouging and a final X-ray inspection, and then it is ready for the shipment. And here it is the manufacturing process of the nozzle guide vanes. It starts with a wax pattern injection molding. Then it's immersed into a ceramic slurry. After having the desired thickness, it is let to get dry and then dewax the mold at 900 degrees for 1 hour to burn wax remains. Then the ceramic cluster is wrapped by an insulation layer. Thermocouples are set on the assembly before entering the casting furnace. Then the assembly is removed from the furnace to allow it to cool. After that, the as cast is cut into smaller specimens for porosity analysis. The specimens are ground and polished to the mirror-like surface using metallographic techniques. Then an optical microscope is used for porosity characterization, and finally a quantitative analysis of porosity is performed using an analysis software. There are different casting processes, for example sand casting, which consists in pouring molten metal into a mold made of sand. The permanent mold, which is more or less like sand casting, but in this one the mold is made of metal which can be reused. Centrifugal casting, where molten liquid metal is poured into a spinning die. Or die casting, where the plunger makes pressure and the molten metal of the chamber flows through the gooseneck to the mold. But in this case, in both parts is used investment casting. Now, here we have the steps of this investment casting, which is particularly different because in here, the molten metal is a nickel-based alloy. In this image, we can appreciate the cross-section of an investment mold and get a better idea of how it works from the inside. Here it shows 4 parts made at the time, but let's imagine there's only one part. In the image A, we see the wax injected to form the pattern. Then the wax pattern is immersed into a ceramic slurry to get a cluster. Then in the image D, we can see a cluster with the wax removed by melting and evaporation. So finally, in the image E, the mold is turned around to get the molten metal pured, and finally we have our piece formed. After seeing this, there's one thing we must consider when casting a piece, and it's how much excess material to include to be accurately machined to its finished dimensions. For this, we must think about the allowance, which consists in oversize the piece. In this case, because of the shrinkage of the molten metal, so at the end the final dimensions are the ones desired. After knowing this, we can think about designing a high volume process for these parts. For the engine airfoils, I would think in a multi-cavity mold because the pieces aren't so big and we could make more of them at the same time. But for the nozzle guide vanes, a single cavity mold would be better because it's a bigger piece. Now, along the years, metal parts in machines have been substituted with plastic parts because it's cheaper and easier to produce. In this case, the parts work with temperatures over 800 degrees, so we will need plastics that supports these temperatures, which actually there isn't a plastic that can support it. But maybe in the future could be a plastic that can replace these metal parts, making them cheaper to produce and maybe make them recyclable, which would be better. That will be all, and thanks for your time. Goodbye.